I'm Blake Garner. I'm a lead cloud architect in our cloud operations organization. I've been at Adobe for around 20 years. I started in hardware compatibilities labs and then launching our private cloud. And now I'm focused on company-wide security services. So, Adobe. So my home is in Seattle. Here you see a picture of the Adobe Seattle office. Adobe's products and services are categorized into 3 clouds. We've got Creative Cloud with things like Photoshop, Premiere, After Effects. Experience Cloud is our digital marketing tools. And Document Cloud is Acrobat and all the friends and services that go along with that. Adobe is a multi-cloud company when we produce services and when we consume infrastructure. So we've been running Vault as a service at Adobe for quite a while now. And just to clarify, that means Vault Enterprise Software by HashiCorp. Thank you, legal team. The Cloud Operations Security Solutions team, of which I'm a member, provides Vault as a service for all the product teams. And Adobe is a company formed by many acquisitions, and that results in many internal services and platform teams. Primarily Vault's serving up a lot of KV2 secrets, but looking forward, we're going to be standing up an internal PKI authority, and we're looking at some interesting use cases around that. Last year in the hallway track, we talked about moving to AWS Graviton instances and using integrated RAF storage in production. So, why am I here talking about growth and scaling? Well, Adobe is always growing. More services are being created and deployed every day. As the centralized repository for secrets management, we have to keep up with this pace. We're currently serving around 2 billion transactions per month, which is up 30% in the last year. Vault performance is a moving target. Recent releases have been focused on improving performance, but we're still chasing that. So understanding your workload is critical, especially if you're operating it as a service and you're not tightly integrated with the product team. So you want to understand things like how many reads you're doing, how many writes you're doing, or what percentage of the overall workload is that versus auth engines and other things like that. So, and if you do have large platform teams, you want to engage with them, understand things like if they have a large release coming up or anything that might bring a big wave of access. So that kind of brings us to capacity management. How much resources are being consumed, how much resources are you providing? And I wanted to kind of share something which I haven't seen at HashiConf, which is people talking about actual hardware that they're running this type of a cluster on. So again, we're on the Graviton 3 instances, and I've listed out some different sizes. With the 5-node cluster being kind of our preferred size, the different 3-node clusters used for regional instances or development environments, that kind of stuff. So 7-node clusters is a thing with RAF integrated storage, but that's something we've kind of avoided due to a perception of a write penalty. But that's something we may kind of revisit in the lab as time goes on. 10-node clusters, so yeah, that's a thing. You can actually add 5 non-voting nodes into your 5-node RAF cluster. And the idea there is, your load balancer will spread that load across all 10 nodes. And so, we found that was helpful for us, but it didn't really solve all the problems we had with scaling. So another change we rolled out this year is directing all write traffic to the leader node via AWS ALB, Application Load Balancer. And so this has been in production for a month or so. We haven't seen any negative impact, but we have seen a measurable improvement in write response times. And then, if there's a change in the leader node and the traffic isn't being sent to the correct node, it just follows the kind of less optimal path that you normally would see in a round-robin configuration. So Now, if I kind of lost you in the Raft details here, this understanding Raft, oops, wrong button. There we are, the laser. Understanding Raft, this is a cool interactive presentation of how Raft works. And if you're managing Vault at a serious level, it's definitely worth the time to go through that to kind of understand what's happening. People start talking about leader nodes and elections and that kind of stuff. All right. So, yeah, answering or predicting when a Vault cluster is full can be difficult. I kind of wanted to have a slide that's like, this is how you know your Vault cluster is full. That's not really a thing. The workloads are transient. You could have, a bursty workload next to another bursty workload for years on end, and then one day they both happen at the same time. That's not something you can really predict. And then again, the Vault cluster performance is a moving target. It gets better with each release. You need to instrument your cluster, understand which metrics are going to show when your performance is being degraded, and you want to know that before your customers tell you. And so, yeah, I've got two sets of metrics up there. The top ones are really about storage and response, and the other ones are about tokens, creation and deletion. So one of the things that can happen is if somebody's got some runaway automation and they're accidentally creating a couple million tokens, over their lunch break, that can be a problem, and you might be able to find that in your observability stack. And you go talk to them and tell them to knock that off, and everybody goes back to eating lunch. Well, the other thing to be concerned about is when all those tokens expire, that's also going to create a second event that will be performance impacting. So you want to kind of keep that in mind. And I call out faulty retry logic. That can be a source of mass token generation. OK, so Vault Benchmark is a new tool that HashiCorp has released to help understand how different configurations of Vault can behave. You can customize the workload to mimic what you've observed in your production clusters. Using this tool in combination with test clusters, you can evaluate how different scaling options work for you. I've provided some test results from a non-production 3-node cluster. I've got the metrics down here on the bottom and kind of the stats of the tests that's run there. So that's just something I discovered trolling around on the releases page in HashiCorp a while ago, but it's a great tool. But keep in mind, it's the stats that it's going to output aren't going to match exactly what you see in your observability stack. It's pretty much a developer type tool, but you can do relative comparisons. If you want to compare a 3-node cluster and a 5-node cluster and a 7-node cluster in the lab, that's definitely what this tool is for. And you can customize what types of actions are happening with Vault. It's pretty comprehensive at this point. And then if you run this against a busy production cluster, you're going to cause an outage. So definitely keep it to the lab. And I like to break things like Vault clusters, in the lab. So what I found is kind of fun is if you run 3 or 4 or 5 of these against a single Vault cluster at once at the same time, it's definitely not designed for that. It will cause your cluster to fail, which is actually really good to understand. Know what your failure point is, know if your storage falls over, know if you run out of memory, that kind of thing. So yeah, cool new tool for the toolbox for testing that kind of stuff. All right, so yeah. So taking a look at the options for managing spiking or runaway Vault clients, rate limiting is really focused on preventing denial of service situations. And that's, it's not distributed, it's just denial of service. So that means if you've got one instance or cluster or something that's coming from a single IP that's hammering your Vault cluster, the rate limiting will kick in and help mitigate that. If you need to limit traffic from large numbers of client IPs, the AWS WAF is your best bet. Rate limits and quotas can appear as an outage to your users if their systems don't understand the response codes. So you want to work with your teams and make sure that their software responds appropriately. You know, if Vault's telling their software to wait a minute before responding again, and they just keep piling on immediately, expecting that, you know, to constantly retry, the rate limiting isn't really going to do its job. So it's kind of a two parts to that puzzle: is set up rate limiting, and then make sure that the software that's connecting to Vault can actually understand what is being told, and not let things run away. Another thing, so lease count quotas, I noticed just doing research for this talk that those exist by default on 1.16. And so, you know, if you deploy a new cluster and you fill it up right away and you hit this limit and you're opening a support ticket, don't open a support ticket for something that's in the documentation. So just, especially as that's just a change that happened within a Vault release, it's something I wanted to call out. Okay, so I'm going to shift gears here for a minute and discuss how we're addressing Vault configuration and secret sprawl. This is another aspect of running Vault as a service. Over time, policies and mounts build up like random files in the desktop folder of your laptop. We're rolling out a Terraform-based system that will manage Vault configuration in an opinionated way. It's expected to reverse the constant expansion of access when teams are authoring their own policy. Another side effect will be using Vault extensible metadata to add ownership information to things like Vault mounts. And in general, we like this idea of complicated simplicity. We want to reduce the user input to a minimum, encode best practices into a Terraform module, and enforce naming conventions in organizational structure. So beyond the dramatic improvements to the existing freeform policy management system, we're able to launch new capabilities via Terraform modules. Adobe has several different internal infrastructure platforms. Using Terraform modules, we can create customized interfaces that configure Vault access, controls, resources with minimal input from the platform system. By building modules for dynamic secrets that include policy design, again, we reduce the needed effort for teams to adopt them. With our PKI modules, we're laying the foundation of an internal certificate authority. And this will deliver on some traditional use cases along with enabling further explorations of service identity via certificates. So taking a look at the configuration for our KV2 module here, we can see an example of how we define a secret structure in HCL. That's this guy over here and here. The first block creates a KV2 mount with subpaths for organizing the secrets and scoping policy. And each of the points along the path have app roles and policies created for people to use. At the top of the hierarchy, we create a directory group so users can access the secrets for administrative type access. And at the very end of the branch, there are narrowly scoped policies that get access via app roles and provide read-only access to the specific secrets needed for a service. So part of providing paved paths is also providing guardrails. Our system is designed with these controls to limit what can be configured within the namespace. By tightly controlling which Terraform modules and providers are available, we limit the configuration options to which ones we have approved. On the GitHub side, we control changes to the available Terraform modules via a pull request process. And then some of the modules are designed for external contribution for things like PKI roles or other cloud provider policies. So with these kind of controls in place, we try to prevent people from going over unexpected cliffs. That's what's behind the sign there. So again, if you go down the path of trying to use namespaces and you already have Vault in production, you run into this, and we call it the bucketing challenge. Sorting teams and services into a new container, and that being a namespace. Friends, it's super difficult to bucket teams into namespaces. So really what you got to do is educate users on what a namespace is. It's not the same thing as a Kubernetes namespace. In the context of Vault, it's an administrative domain, and that is used for delegating administrative access. Ideally you want to have a couple people who may be kind of the Vault experts for that group of people, and those are good candidates for being the administrator. And they in turn can delegate actions, configuration actions that need to happen as well. It's an identity domain, so tokens and configurations for your identity provider are scoped to the namespace itself. And that helps people understand, well, do I want to be a member of 10 namespaces or just one? Or how easy is it to share a secret within a namespace versus crossing a namespace? That's a good conversation to have when you're coaching people about namespaces. One of the other things that we found in our efforts to do this stuff is the OIDC standard can only support up to 200 groups per token when authenticating via IDP interface. And so a large company like Adobe, I'm a member of 400 plus groups over the years, over the 20 years I've been there. So again, using things like a filter to filter on a name prefix and then naming conventions, these kind of pieces all work together to make the thing function. It's also a service consumption domain. So there's built-in features now that tell you how many resources are being used per Vault namespace, and this is super helpful for chargeback and showback models. So yeah, what's this look like? So here's our current deployment, and in this scenario, we're delivering the service of secrets management in the form of Vault clusters. This is in this diagram, we're looking at a simple single cluster deployment in a single region. It starts with the AWS account, which is provisioned by an external system that can give us access to build the infrastructure. Next, we use Terraform Enterprise to lay down our static infrastructure. This includes the VPC, networking, application load balancers, and access controls. All of the components that aren't really part of the Vault clusters themselves. The Vault cluster itself is built using a Terraform configuration separate from the static infrastructure. It deploys the EC2 instances along with their storage, bootstraps the configuration management system. Once the cluster is deployed, we're ready to provision a namespace. So currently, the Vault namespaces are provisioned under a Jenkins workflow. This workflow takes the input of the namespace name and the people who will be the administrators of it. It then builds out a GitHub repo on Enterprise Cloud, a Terraform workspace on Terraform Enterprise, and it configures the identity groups in our internal directory, and then it applies the initial configuration using Terraform Enterprise. We've also built out a suite of test automation to validate that all these pieces are functioning. And it's really helpful for changing modules or other pieces of the configuration. As we make a pull request, it goes through the whole flow, provisions this, confirms that it works. And if we run into any kinks, we can just add new tests to the system as we go. So the namespace configuration holds a lot of the magic, like the KV2 module. And this is a control point that we use to delegate Vault configuration changes to the engineering teams that consume the Vault namespace. And we can easily enable more Vault features by publishing new Terraform modules in our private registry. Here we go. So after the administrators update their Terraform config, Terraform Enterprise runs and then applies the configuration to Vault, and then they're able to log in and use Vault as is configured. If they want to grant additional access via identity groups, they go to our internal identity tool and manage that outside of this process. So the next challenge we're facing is actually getting secrets and workloads to use these new namespaces. We built them, Now we need to get the workload moved over. So we've built out migration tooling to move static secrets and opportunistically reorganize them at the same time. We're focused on aligning with the product team's release cycles and not just some arbitrary deadline to just get it all done. And the Terraform modules create the mounts and the policies and the app roles at the destination using the new naming conventions and all the best practices we've baked into our modules. And then the migration tooling moves the secrets. And the flexibility there is you can pick any point in the vault pathing structure of your source and any point in the vault pathing structure of your destination. And again, we're encouraging teams to kind of reorganize their secrets at the same time. As we continue to develop this tool set, we're working on these future improvements. So, a lot of times somebody will be like, hey, is anybody still accessing this mount? We don't even know if we need it or not. And so we want to kind of be able to answer those questions in a self-service way, especially if there's an engineer who's spending their time doing this migration, kind of helping us out. We're going to give them the helpful tools that we can by processing logs and getting things like when was the last time the secret was used, and if it's being accessed, like what are the source IPs of those systems accessing it, so they can go track it down. So again, bringing it back to scaling a little bit here. So while we were building this out, this new way of managing the Vault operations team was still having challenges with oversubscription of extremely active Vault clusters. So at a certain point, you need to start considering scaling out. We had to start answering questions like, can't you just give us our own Vault cluster? And that way we can mandate the maintenance windows of our Vault clusters. And then if you have one team that has a Vault cluster, you get another team saying, well, we want our own Vault cluster. And things like, we're not ready to upgrade because it doesn't work for our timing. And then you end up with a lot of operational burden that comes from that. So really, it's best to rely on your capacity management framework primarily and avoid customer-dedicated clusters. But eventually, adding a second cluster to land some workload needs to happen. So I'm kind of going through like what that might look like. Because Vault is not infinitely scalable. So looking at the tools in our toolbox, we're exploring the idea of multiple clusters in the same region. And that's kind of where the idea of, well, what if we treat each Vault cluster as a cell? And so kind of here's what that would look like with the tools that I've been discussing here today. So the first two layers are the same. They're common. You've got your static infrastructure in your AWS account. And then we add in the remaining components. So in this case, we're going to have a second Vault cluster. And then we're going to create that Vault namespace. And then we're going to apply the namespace configuration. And then we're going to end up with Vault mounts. And so one of the overall things that ties this together is another bit of magic that we put together, which is, again, using the AWS application load balancer to read the namespace header that gets sent when you're issuing a Vault command. And the application load balancer will say, hey, this namespace is, it's the new one in the new cluster. And that traffic will be directed to that cluster. And so that's a way that you can, essentially shard the workload across multiple clusters. But you still have the same URL endpoint for your Vault cluster. And then, someday in the future, there may be a way for us to actually move these namespaces to a new cluster. If one got too busy, we could say, hey, you know what? We need to just shift this workload. So we're definitely exploring ideas there on how to do that. So yeah, just kind of a quick recap. Scale up first. That's definitely the easiest thing to do. Spend a little money with your cloud provider, scale up to 5 instances, that kind of thing. Graviton does seem to be a bit faster than Intel instances, so look at that as well. But then right away, work with your Vault service users. Your consumption of the cluster may not be, legit. It may be just a waste. There could be people doing things really inefficiently, And you should be able to track those people down and figure out what they're doing. Maybe they're not. In the process, you might learn about their plans of deploying tons more infrastructure, and you want to engage with them at that. Definitely look at rate limiting quotas. It's much easier to have the conversation about somebody bumping into a quota that's been there all along than going back and having to say, hey, you're really using a ton of our service. We need to put a quota on you. It's much easier to do that beforehand than after. And then, yeah, namespaces, when you get to that scale, are really helpful. Definitely look at organizing users and services into namespaces. And then back to that complicated simplicity idea, relieve users from creating vault policy. Bake in your best practices to your automation. Provide some guardrails. Don't let people go off a cliff, make 10 million tokens accidentally, that kind of thing. And then if you get to that point, consider moving your workloads to an additional cluster. All right, that's it. Thanks for your time. I'll be around the conference if you've got some questions and would like to chat with me about that.